Hey guys, welcome back to the Geography Academy. Remember, this video is just a small part of a much larger course that's available below if you just follow the links and instructions. AQA, Coastal Systems and Landscapes. Then we're looking at three major sections in this unit. There are three big sections. We have the physical processes and characteristics along the coastline to understand and to help explain the section 2 and section 3. So definitely do it in order. Start with part 1, then part 2, and then part 3. Please don't skip ahead unless you're really confident with the knowledge and information and vocabulary associated with the processes and the characteristics. All right, here we go. So we've got different areas of the coast. We have the backshore, nearshore, and offshore zone. A lot happens in the nearshore zone as that's where the waves are breaking, and the backshore zone then changes over time. We'll be making references to this as we go. Often the coastline then is split into two types. We have high energy coastline and low energy coastline. The high energy coastline then sees a lot of erosion, and we see the low energy coastline then can have a little bit more in terms of deposition. For coastal inputs, processes, and outputs, we think about it like a system whereby we've got inputs of things like energy, processes like transportation, and outputs like new features being formed through deposition. Waves are a key process here to this. Waves then are bringing in the energy and changing the coastline area. So when we're going through this, the best way to think about it is that we'll learn some of the processes and keep that in mind, the concept of a system being there. Once we understand all the physical sections in Unit 1 and Unit 2, we can come back to this idea and then discuss it and how it's changing and the equilibrium that is met at this point. Understanding waves then is quite important. The fetch refers to then the distance the wind travels. So if we have island 1, 2, and 3, the concept here is that the distance between island 1 and 2 is greater. So if the wind is coming from 1 to 2, we would tend to see that it has a larger fetch. And due to this, we would expect that the wave energy that comes from island 1 to 2 would be greater than coming from the islands between 2 and 3, let's say. Now, this can often be the distance between an ocean or a sea, right, rather than what we can see in this example. So how does this change the anatomy of a wave? Well, if the sea is very calm, the fetch is very low, and there's very little wind, we would tend to find that it then has a calm sea level with a very short wave height. If we increase the wind speed, the friction transfers kinetic energy into the waves through the wind, and this creates then a higher wave. So that wave height can then decrease the wavelength and frequency potentially in those areas. We see then the energy being transferred in oscillations into the water. So as you go deeper, if you go like diving, for example, you're going to get to a certain depth and the waves won't impact you as much. But on the surface, that's when the energy will be at its highest. As the wave comes into the coastline, then it begins to reach more shallow land where the oscillations then become more oblique and then they start to shoal, or this is the shoaling process as they get into more shallowing water and the energy becomes disrupted. So it's a lot like if you're riding downhill on a bicycle uncontrollably and you pull the front brakes. More than likely the energy is stopped at the bottom but continues then to send you over the top of the bicycle. Hopefully not though. Okay, so in the wave action here, the waves move forward in swash and they go onshore on the swash and they come offshore on the backwash. Now, as they're coming in, they can be carrying sediment and then will cause things to happen during swash and backwash. So a high energy and low energy environment, a low energy environment here for the constructive wave, short wave height, long wave length, gently sloped profile, and gradually spilling waves. This creates a stronger swash, meaning stronger swash than backwash. This is because it starts to break further out, so the energy is slowly being dissipated as the shoaling process begins further out in a more gradual way, meaning that deposition happens on its way in, and then as the wave breaks on the shore with little energy, it deposits what it has left, and then a weak backwash returns to the sea. On the other side, the break happens very quickly. High energy wave is then able to carry more sediment a little bit further, crash onto the beach with high energy, and is able to cause more erosion and a stronger backwash. So a powerful breaking wave will have a very powerful backwash which will come back carrying sediment off the beach with it. So it could have brought large sediment onto the beach and taking small sediment off the beach, and sometimes that gets deposited then in like an offshore bar or something like that. In this area here, we see a constructive wave, so gentle profile. We can see there's not much change in depth offshore, and we'll create a gradual spilling wave that comes in. Here it's a bit more of a high energy coastline. We can see the bigger waves out here crashing into some sort of rock out there. So the waves are building up and they bring a high energy, and they're still at like quite a depth when they come in here. They start to break closer to the shoreline then, and we can see some kind of the wavelength is actually quite increased on this one here. But it's bringing in quite a high energy with it as well. So this will be actually bringing quite a lot of sediment onto the beach and would be a breaking wave rather than a spilling wave. So the type of waves are very important. We're going to combine all this information and recap it when we're talking about the different features. Here we have the tide. So the tide is working in a number of ways. It is going to have the gravitational pull of the moon and the sun. So when it reaches certain points, like the moon comes around to that point there, it's going to be extra strong because it's going to be